Hello friends, this is Durga again from Technology Mentor / IT University. As part of building enterprise data warehouse, so far we have seen creating the databases, creating the tables, load data from relational database into Hive databases using Scoop as well as Hive. And the Hive approach can be used not only for relational data sources but also for other sources. So we have three databases for our retail database in Hive, and those are retail EDW, retail ODS, and retail stage. This let me drop this database called retail underscore ODS underscore stage and drop table retail underscore ODS underscore stage dot orders, and then let me drop this database just to avoid confusion. And now if you run the show database, there are only three databases: retail underscore EDW, retail underscore ODS, and retail underscore stage. So retail underscore stage is used to stage the data before loading into ODS. That is the first level of launching first database where the data will be launched from several sources. In our case, we have ran scoop import all tables command to load data into retail stage. So you can connect to retail stage database by using use command. And in this you can see there are a bunch of tables. Okay, customers, departments, delta, order items, orders, and products. Okay, and when we actually try to demonstrate Hive load command onto retail ODS database directly, it failed for orders and order items because there are some transformations that are happening under orders and order items under the second database called retail underscore ODS. First, let us review the differences between order underscore items between the source database and ODS and see whether we can use stage database directly. If not, we will try to see how we can overcome this issue. Okay, so let me review the orders first. You can see that orders have 4 columns: order ID, order date, order customer ID, and order status. And if you go to retail underscore stage, and also data types are int, date time, int, and varchar. And if you go to orders table in retail underscore stage, right now we are underscore retail we are under retail underscore stage database. And if you describe formatted orders, the table uses Avro format. So it input format is Avro, container input format, and serialization deserialization framework is Avro Serde. And you can see that it has 4 columns: order ID, order date, order customer ID, and order status. But order date is big int. And if you review the data of orders under retail underscore stage database, which is populated by scoop import at the beginning of our course, it will take time because it has many records. So if you see, the date is represented using a integer value or big integer, and converting this to date has to be done before we load into orders table if we want to use this one. So there are discrepancies between the source table in the source database, table in the stage database, and then you can also say describe formatted retail underscore ODS dot orders table. And you can see that this table is partitioned and the order date is string, and the partition column is order month. I want to partition by order month when it comes to table in ODS. Okay, that being said, there are discrepancies between source MySQL, source table in MySQL database, and stage table in retail underscore stage, and the ODS table in retail underscore ODS. So first we need to make sure that stage is same as the source table in MySQL database when it comes to orders. Now let us review the order items. Order items have 6 columns here, and even in stage database, use retail stage. You can say see describe formatted order items, and here also it has 6 columns and it is not partitioned. So but when it comes to retail underscore ODS, we have 7 columns, and the additional column is order date, and this order date we want to populate using orders table, so that our downstream fact tables can be populated more quickly. So our data model is a little bit denormalized when it comes to retail underscore ODS database, and also the table is partitioned. So there are subtle differences between the table in source MySQL database and retail stage database versus the order items table in retail ODS. So we need to apply all these kinds of transformations and load into this final table, which involves using our insert command, applying transformations using select clause of the insert command, and load into the final table. So now let's start with orders table. We cannot directly use orders table. Instead of applying transformation, I will load the orders data from MySQL database into retail underscore stage database, and then I will use that one to load into retail underscore ODS database. And already there is a table called orders in retail stage with the name orders. So I want to create a new table here, which is similar to the source table, except that the delimiter and everything else will be same. So already I have this hive.ddl.txt which is used to create ODS table. In that I want to just change the table name. I want to use it as stage orders underscore stage, and then the column names are same, and I don't want to copy the partitioned clause, so I am removing the partitioned clause, and I'm bypassing the partition clause, and I'm using row format delimited and stored as text file here. Now I have the table orders underscore stage in retail underscore stage database. Now I have to populate this. For that, I have to run this command to export data from orders table into temp orders.psv, which I have already done. So here I will use that path, load data local in path /tmp / orders.psv overwrite into table our new table name, which is orders underscore stage, and hit enter. Now the data is copied into orders underscore stage. You can do select star from orders underscore stage limit 10, and you can see the data is proper. If you look into orders table, which is in retail stage, this is represented in big int, and you will see integer values here. Now it is having date. So we just need to apply necessary transformation logic to load our partition table. Before loading into partition table, we need to make sure that dynamic partition is enabled, because we don't have partitions pre-created on this table. If you want, you can pre-create the partitions. If you don't want, you can use the dynamic partition approach, for which we need to review the values of Hive execute dynamic partition. Set Hive execute dynamic underscore partition. It is set to true, and mode is also already set to non-strict, so we can directly use insert command with the necessary transformation logic to load into the orders table under retail underscore ODS. So first let us review what is there in retail underscore ODS.orders by running the describe formatted command and going to this location. I'm running dfsls command to see if there are any partitions already. No partitions, nothing. The table is completely empty. And now let me run the insert command. Insert to overwrite into table. Our table name is retail underscore ODS dot orders. Okay, and I have to give the partition clause because we are trying to load into a partition table. And here you have to give the partition column. And then you have to give select. What are the 4 columns? Order ID, order date, order customer ID, and order status. And then we have to apply the transformation logic. Hive already have user-defined functions called substring, which I will review when we actually talk about HiveQL. In this case, I will not get into too many details. Substring is the function where you can actually pass a column name and tell what from which offset to what offset you want to extract the string. So you are trying to extract substring of it. As you guys are might be familiar with SQL, substring is a very standard function. In this case, to capture year and month, because we want to partition by month, I have to grab these 7 characters y minus mm format. So 1 comma 7, so substring will return those 7 characters, and then I just want to give an alias. I think giving alias is mandatory when it comes to Hive. And then from what is the table name from which we want to copy the data, retail underscore stage dot orders underscore stage, and hit enter. What happened? Insert override table, I think. Yeah. So insert override will replace all the files if there are any under orders table, which is under retail underscore ODS this time for this insert command, and write the new data. And under the covers, it uses map reduce to run this insert command to load into the final table. And you can see that the loading partition, and you can see something with column name as the prefix, then equal, and then y minus mm format of our order date, which is our transformation logic. That being said, now let us review the path and see we have directories for each month with the same format as the column name as prefix, and then equal to, and then the value for that list partition, which will have the data related to whatever month we are trying to store in the directory. And now you can do select star from limit orders, select star from orders limit 10 and review the data. Here we have to give retail underscore ODS because we are under retail underscore stage database. That's why it is showing improperly. But under retail underscore ODS dot orders, you can see 5 columns, and the last column is month, and the month is derived from the date field. Now orders is populated using minimal transformation, and if you look at retail ODS, you can see that there is no data under order underscore items here. Okay, and already I have reviewed, it has 7 columns plus order month, so 8 columns. Order month is the partition column, and order date, there is no order date in the source data, so order date is the derived field from orders itself. So this insert command to order items is not just plain load or insert from the source database. We have to do join with orders before loading into our final table. So to achieve this, we can tackle in multiple ways. One is do the join on the MySQL itself, and then export to a PSV file, and then load that PSV file into stage table, and then copy that to the final table. Or the second approach is use Hive itself to do the join and insert into the retail underscore ODS table. We will take the second approach, and already retail stage have orders data in orders underscore stage in the required form in the desired format as us. And also there is another table called order items in retail stage, and you can see that data, all the other fields than order month and order date are already available in this order underscore items in retail stage database. and the data here is retail underscore stage dot order underscore items, and data here is of type Avro. So we will be querying data from Avro, data from table which stores in Avro format, which is order underscore items. Then the orders underscore stage is of text input format in stage itself. We will join these two and load into our final table, which is under retail underscore ODS. Order items is text input format table, which is partitioned by order month, which have order date field in that. That being said, now let us review all the columns to describe order items. This is in our retail underscore ODS database. We are connected to that at this time, and I have to load this table. So insert overwrite table order underscore items, and then partition order month, and then select order item. So let me say OI dot order item underscore ID, OI dot order underscore item underscore order underscore ID, and then O dot order date, because orders table have order date as order date only. It is not order item order date. That's why I'm giving O dot order date. So when we actually join in the from clause, the alias for the orders will be O, and alias for the order items will be OI. That's why I'm prefixing with OI for the first two fields and order O for order date. And then I have to type the rest of the fields, and then I have to apply the transformation of substring O dot order date, comma 1, comma 7. Or I can actually query directly from orders table also. There is no harm in that. Orders table under retail underscore ODS. But now I am actually querying from retail underscore stage for both. So I am trying to use the table in orders underscore stage itself. Sorry, orders underscore stage from retail underscore stage itself. But it is absolutely fine to join order items from retail stage and orders from retail underscore ODS before populating to retail underscore ODS order items table. Anyway, so now from clause, okay, I have to give the alias order month from retail underscore stage order items join retail underscore stage dot order items join OI, which is alias, join retail underscore stage dot orders underscore stage O on OI dot order item underscore order ID equal to O dot order ID. Let me review the column name. Yeah. So orders is a parent table on top of order items, and these two can be joined using order ID and order ID of order items table. So that's it. Hit enter, and now it will run a MapReduce job to join these two data sets of orders and order items using the join condition and also the necessary transformation, and the final output will be inserted into the retail underscore ODS order items table in applying the transformation as well as partition. So it is almost done. Now first do select count of 1 from order items. Now I am actually reviewing the data. We have 172,198, and then describe formatted order items. Take this path, and you can see all the partitions in that location with the month. And let me validate the number of order items in MySQL database also. It is 172,198, which we got when we run select count on the order items which is just copied. And let us validate the data. Select star from order items limit 10, and you can see there is the order date here, but there is no order date in order items table in MySQL. But now we have joined, we have done the necessary transformation to compute the order month also, using which we have actually partitioned the table. The reason why we have done this is that to do the joins effectively between orders and order items before loading into the fact table in retail underscore EDW when we actually want to generate data for our reports. So this is how you can leverage the insert statement and come up with your ETL framework. It involves getting data from source database into a stage database, and then you apply the necessary transformations before loading into the final tables as part of your ETL framework. And this is a multi-step process. You cannot do it in one step, and it involves not just Hive logic, Hive knowledge, but also other technologies like ETL tools or shell scripts, whatever way you want to develop wrappers on top of these Hive queries. And I have not covered all the transformations that can be done. I will be covering those things as part of HiveQL itself. At this time, I only focused on demonstrating the insert command, not the HiveQL completely. So I have done bare minimal transformations in this approach. But we will see HiveQL a lot more in detail going forward. That being said, I hope you are enjoying the content so far on my channel. If you like this video, please click on the like button. If you want to provide feedback or ask any technical questions on that particular video, please leverage the comment section. And if you have not subscribed to my channel yet, please do so. You will got to see a lot more content than just Hadoop and big data over time. Thank you. Bye.